We start by factoring these into real factors, that is using only real numbers. And this is how he factors using a couple of formulas. And this is as fast as we can go because these will have complex roots. However, the basic theorem it says that any real polynomial can be factored into these particular patterns. Linear factors times a bunch of irreducible quadratic, and they have complex roots. And the linear one, of course, produces real roots, in this case, 2 and minus 2. And the quadratic produce complex roots. If we allow complex number, we can factor this further by first finding all the complex roots and using quadratic formulas. And in particular, then this one, we can use its root, and it will break up into these two factors. And similarly, this one will break up into the following two factors. And this is the complete factorization of the using complex numbers. Notice the complex roots, they always come in conjugate pairs because they came from quadratic formula with a plus and minus. And therefore, this helps us to put these roots back into the formula where they came from. For examples, if I want to find a formula with 2 minus I as a complex root, then I know 2 plus I must also be a complex root. What formula has these two as complex roots? We make these two numbers, and 2 times a and a squared plus b squared. And here is how we make up that second degree formula. You put 2 times a over here and a squared plus b squared over here. In our case, it turns out to be x squared minus 4x plus 5. And these will have these as two complex roots. But we also have at 1 has an order 2 roots. So therefore, p of x must be this order 2 root at 1. And these complex produces these complex conjugate roots multiplied times some numbers, okay? And to determine what this number, I need more information, and that's called initial condition. So in this case, suppose the initial condition says we put 0 in, I suppose to get 10. This says if I put 0 into this formula I got for x, I suppose to come out to be 10. That says 5 times k is equal to 10, so k must be 2. Hence, in this case, we have the particular solution 2 times this entire formula. Basically, then this says also that every polynomial of n degree can have n roots, complex number. This says complex numbers complete, solve every equation. So that's what it meant. Okay, bye-bye.